Hello everyone. I would like to explain my project Car Black Box. My name is Sajaruddin and my teammates Ganji Vivek, Ayral over there Reddy. Okay, first of all go to what the contents of my project. This having what is car black box requirements, embedded systems, microcontroller and microprocessor, CLCD, digital keypad, ISR, timer, I2C protocol, WEEPROM, project implementation, and the last project implementation. So first of all, I want to discuss about what is a car black box. So a black box is a device, is an 18-wheeler that document information about a particular commercial motor vehicle's movement over time. Okay, car black box nothing but is a electrical device capable of recording event associated with car. These devices is widely used airplanes. Nowadays also in cars, trucks and other vehicles, mostly used in investigation car accidents. Like that we are using car black box. So a black box is either physically installed in the car or downloaded as a smartphone app. It links to a GPS device that measures and records vehicle speed, location, distance traveled, driving frequency, and time to day of the car is in motion. After a car accident, it is important to determine how a car crash was caused and what factors influenced the crash. This information helps prove liability after an accident. Car black box records the following accepts: acceleration speed, airbag development times, braking activity, seat belt use, steering angles, vehicle tilt. So let us discuss about what my requirements. Knowledge um, knowledge in embedded C, MPLab IDE, XE8 compiler, PIC, SimLab, PIC 16F877A, 16 into CLCD, digital keypad, potentiometer, timer, WEEPROM, real-time clock. Okay, now let me tell you embedded systems. So embedded systems is a combination of any hardware and software, which is nothing but it is a combination of software and hardware. It performs a specific task. Then GPS, general purpose system, it is used to perform large number of tasks. Okay. Then types of embedded systems, so we have standalone system, real-time system, networked, mobile. Standalone system, so we are all well known about washing machine, right? So first of all, your slave system, these systems are not intelligent even though these are embedded system. The system cannot take action by their own. So example, let be washing machine. And second one, example, real-time example, independent system. This system can take action by their own. Let's take example, Google car, driverless driver. Now real-time system, these systems are time-bound system which will take action on a specified time. Failures in this system are not acceptable. Hard real time, from real time, software real time. Example, airbag system. We are well known about what is airbag. So let's move to the now network system. This system which are connected to the network. Example, home security systems. So that may be IoT. We can control over with our hands, remote controlling, like that. Then mobile system, the system which are movable are called mobile system. So it may be robots, robotics. It is. So I already told embedded system is a combination of software and hardware. So this architecture tells the software and hardware how it will take parts. So software is a out like outside parts, hardware is a inside. So software is sensors, auxiliary system, FPGA, OSIC, memory. Hardware coming to the hardware, DAC, ADC, human interference, diagnostic port, SOC. So these all software and hardware's architecture. To choose embedded system, we have to keep some points in our mind. So it should be low power consumption, cost efficiency, efficient use of processing power, reliability, efficient use of memory. These all points we have to keep in our mind while we choosing embedded system. So microprocessor. Coming to the main point, an integrated circuit chip, which is capable of being programmed to perform a specific task. So already told, embedded system is used to perform specific task. Okay, right now it has a design restriction such as memory size, I/O capabilities, that means input-output device, peripheral functions, etc. Choose a microcontroller based on. We have to choose. Microcontroller is nothing but a chip. Uh, so we have to choose that chip having applications, performance, price, availability of tools, special capabilities. Microcontroller, all components will be in a single chip, less flexible, less design complexity. Then microprocessor, all components are assembled separately, more flexible and more design complexity. This is the big microcontroller. I will discuss about in simulation of our project. So let's move to next. This is the architecture of PIXSIM lab. Tackle switch. This is one type of switch. Tackle switch is allows electricity to flow in one circuit by manually preserving the operating section. Okay, this is a pull down the resistor circuit, also pull up resistor circuit having so I said tackle switch is a switch is operation perceptible by touch. This switch will produce a bouncing effect when a switch is pressed, provides a simple and cheap interference, comes in different shapes and sizes. Some common applications of tactile keys or HMI, mobile phones, computer mouse, etc. Digital keypad. So this is a digital keypad in which number of tactile switches are connected in rows and columns concepts. These used to when more number of users in inputs and are required and still want to save some controller input output. These keypads are most commonly used in telephones, calculators, digital lockers, etc. CLCD. So first of all, CLCD means character liquid crystal display. We can whatever will be operation that display in this section, we can see what our uh, operations is done our chip. So like that. So in PIXSIM lab there are two types of display. 16 to 2 display, 16 to 4 display. It display the ASCII character and some special characters. 16 to 2 means 16 characters and 2 lines. It has 16 interfacing lines. Two types of communications mode: 4-bit mode, 8-bit mode. So coming to the interrupts, an interrupt is a communication process set up in a microprocessor or a microcontroller in which an internal or external device requests the MPU or MCU to stop the processing. Then the MPU or MCS acknowledges the request and attends to the request, goes back the processing where it was got interrupted. So polling. So polling, it is a process where the computer or controlling device waits for an external device to check the read lines or state, often with low level hardware. So disadvantage of polling. So loss of events may occur during polling, poor response, less power management, classification of interrupts. So interrupts are two types, hardware and software. Again, hardware have two types, non-maskable, maskable. Now maskable have two types, external and internal. These all are types of interrupts. Now coming to ISR, interrupt service routine. So an ISR is a software routine that hardware invokes in response to an interrupt. ISR attends to the request of an interrupting source by clearing the interrupt flags and should save register contents that may be affected by the code in the ISR. It must be terminated with the instruction RATI. When a interrupt occurs, the MPU completes the instruction being executed, then it disables global interrupts enable, places the address from the program counter on the stack written from interrupt. So let's see here. This is a sequential execution of program commands. Whenever the execution of program commands in sequentially, while uh, whenever the interrupt is coming in between, so the program points to program control jumps to ISR. ISR executes to compilation and then coming back to where the interrupt is interrupt that point, then it will execute sequentially manner. So I2C protocol, the inter-integrated circuit or I2C protocol is a way of serial communication between different devices to exchange their data with each other. It is a off-duplex bidirectional two-wire bus system for transmitting and receiving data between multiple masters and multiple slaves. I2C is a synchronous protocol. So it is also called as two-wire interface. Master is the one which initiates a communication, generates a clock and terminates the communication. Slave is the one which is handled by master, acts according to the master command. It can also be possible that multiple masters can communicate with multiple slaves. So see here, slave 1, so slave 2, slave 3, slave 4. So it will communicate from master 1 with also master 2. So this is a multi-master mode. Okay. So I2C bus speeds. So bus means a combination of wires. So first point, bidirectional bus. Standard mode, it takes 100 kbits. Fast mode 400 kbits. Fast mode plus it will take 1 megabits. High speed mode, it will take 3.4 megabits per second. Unidirectional bus, ultra fast mode, it will take 5 megabits per second. It uses push pull drivers. Potentiometer, the potentiometer serves as an analog input to the microcontroller. Potentiometer is a peripheral which can regulate the speed. Analog to digital converter is used to convert a signal from analog to digital. So that is A to D. So converter model have 5 inputs for the 28 pin devices and 8 for the 40 or 44 pin devices. The conversion of an analog input signal results in corresponding to 10-bit digital number. So this is the resolution. ADC register with 8-bit. So it will take a 0 to 255, 10-bit 0 to 1023. So 12-bit 0 to 4095. So coming to the timers. Timers is important applications in an embedded system, which is default peripheral which maintains the timing of an operation in sync with a system clock or an external clock. It has many applications such as measuring time, generating delays, etc. Time control is a software designed to count the time intervals between the events. So resolution, which is also called register width, 8 over 16 bit, etc. So it is referred as a change from one number to another number. It may be up count or down count. Quantum, which depends on the system clock settings, is a measure of time which is responsible for the tick. Scaling may be free scalar or post scalar, maybe 1 is to 1, 1 is to 8, etc. like that. So modes of timers are controller, PWM, that is pulse generator, PW or PP measurements. So WE-prompt, it is an electrically erasable programmable read-only memory. So a WE-prompt is a prompt that can be erased and reprogrammed using electrical charge. The size and component of storage depends upon the requirements. There are three memory blocks in each of the PIC 16F876A devices. So the PIC 16F876A 8778 devices have 8K words x 14 bits of flash program memory. These devices have 128 or 256 bytes of data WE-prompt depending on the devices, with an address range from 00H to FF. So because of it is 8 bit. WE-prompt data memory allows single byte read and write. The flash program memory allows single word reads, 4 word block writes. Okay, well, so let's get into the project demo. This will be continued by my teammate Ganji Vivek.
This is the Pixim lab. First of all, we want to do some settings. It is default shows Arduino board. We can change the PicGenius board where our project output will be shown. Select microcontroller PIC 16 F877A. Set clock to 20 MHz and LCD to 16 cross 2 display. Let's explain the components of our project. CLCD, LEDs, tactile switches. This one is the potentiometer. WE-prom, this is memory. PIC 16 F877A microcontroller and real-time clock and reset button. We can load the code in load X. It default event is on. This one is time. This one is speed. We can change the speed in use of potentiometer. RB0 is collide switch. This one press. This is collide event. After RB1 is click on gear is Newton. Click RB1, gear is reverse. Click RB1, gear 1, gear 2 and gear 3. Event is gear 4. After reverse the gears, you can use RB2 tactile switch. Press the switch, gear 3, gear 2, gear 1 and gear reverse. Gear is Newton. We can use RB3 and RB4 switches using up arrow and down arrow. By clicking any of the button, they ask enter password. The password will be set in program in 4 digits. So enter correct 4-digit password. RB4, RB3, RB4, RB. We can password is wrong type. After 3 attempts, block the user for specific time. Enter correct password. RB4, RB3, RB4, RB3. This is the correct password to enter into the main menu. View log and clear log. And next one is change password. First you go view log. RB5 switch is enter button. It acts. You can press the RB5 switch. You go to the in menu inside the menu. This one is the serial numbers. This is the time. This is the event. This is the speed. We can change the serial number automatically. Gear also event also changed. We can change the serial number 1, 2. Gear event also changed. We can change serial number also 3, 4, 5 up to 8 serial numbers. You can also reverse the also serial numbers 6, 5 gear reverse, 4 gear Newton, 3 gear Newton, gear reverse and gear 1. And second menu is clear log. We can press the RB5 switch. Logs clear successfully. Earlier logs will be clear. You can go to the third menu. Third menu is change password. Enter the button. Enter new password. RB3, RB4, RB3, RB4. Re-enter the new password. RB3, RB4, RB3, RB4. Password change successfully. This is completion of our project. Thank you for give good internship from MNTechs. My special thanks Rajni ma'am, who was our trainer. Then lot to do this project.